guys, and welcome back to this one. Today we are going to be looking at something interesting, and basically the start of a new short, let's say, part or series within the series of the element of programming interviews, and that will be circular queues. So we're going to be taking the question: implement a queue API using an array for storing elements. Use API. Your API should include the constructor function which takes an argument and capacity of queue and queue, the queue functions, a size function which returns the number of elements stored, and implement dynamic resizing. So just to speak about some of the functions that the API should have. So the queue basically means obviously adding to the queue, and enqueue basically means obviously means adding to the queue. Checking the capacity of the queue means obviously checking the capacity of the amount of, or like how much the queue could carry. So yes, this time around the queue is going to have a specific amount of values it could carry. Then the queue obviously taking away stuff from the queue. The size function, which obviously returns the number of elements within the queue. Now, not the capacity. Very, very important distinction. There is a capacity and then there is a size. And then dynamic resizing, something that could then help us increase the capacity. Now, we are going to look at the brute force for implementing something like this. Then so we will now go ahead and look at say the optimized version, where we now get to speak to having this done at specific what do you say, complexities, optimized complexities. This probably looks to cook a sweet and interesting story, blah 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 blah. I think this was just my notes at the time, but yeah, it basically says exactly what I've just said in my own terms, basically. Yeah, some words you see there. So linear queue, it says so we're taking the linear queue and we define linear queue, and then we instantiate it, have a list within it, and now we enqueue. Now obviously we are supposed to have a size capacity for this one, right? But using the brute force approach, we are just trying to illustrate how where there is waste using this approach. So basically, not all the features that we find here will be for the brute force, but we are going to see all of them in full action when we work on the brute force. So basically, we have just a queue, and then we have enqueue being to append onto it, and then we have the queue being to what, take away values from it. Now we say this will do a shift of all the, so basically we are appending from the back, right? And then we have to be popping from the other end, because as earlier discussed in previous chapters, how queues work: first in, first out, right? So it says, so what happens is that when we pop, right, when we pop from this thing that's at the index of 0 after appending from the back, what we would have is that every stuff will shift, every list, every value in the list will shift to the left, right? Because if A goes away, B will become O, right? Right, it will go from index of 1 to index of 0, say O, right? So index of 2 to index of 1 for C, index of 3 to index of 1 for D. And then we now have, and that will make us mean that we are going to interact with every single node for every pop. So obviously that's naturally an O of N. Then we resize. To resize, this is O of 1 because we just append to the end of the incoming. Not necessarily the idea. When we get to what do you call it, up to the optimized, you will now begin to see what we are talking about, because obviously here we didn't put an enforcement of capacity, and what that means was that, means that we're just Basically, we are just vibing. Because if I would say to increase the size in a sense where maybe let me say we said, oh, we have a constraint, you cannot get past 10, this thing, capacity of 10, then to increase that would be probably O of n. That's to say double that in a sense, rather, would be O of n, and you would have to, append like an entire array or something like that. But it will begin to make more sense subsequently when we get to the optimize. And then size, to check the size, we call O of one, which is length of the array. O of one stored by Python is okay. You just write it as O of one. So Python stores the length internally, does not count elements one by one. It instantly returns the stored size. So yeah, so Python helps us do a good job there. So basically, we see that complexity for enqueue is 1, dequeue is 1, and this is what we are trying to change, and this is what we are going to look to change in the next episode where we talk about this guy. So yeah, that's it for the circular queue. It's just basically an introduction, just to they ease us into what to expect in the optimized version, right? Maybe to give a graphical illustration of what we are doing, basically we have a queue, right? And basically this is a list, what we already know, right? So basically we are bringing in values into the list, and we are popping from here and adding from here. So adding is O of 1, but every time we pop, this guy over here now has to move, and also his predecessors. And because they move, this is 3, 2 is left. So yeah, because they move, now we have maybe let me just use O to signify an open space. So we have these guys over here. We now have an empty space over here. Size has reduced and stuff, and then we have these guys move. So because of that movement, that's where we get our O of n for what? For what? Dequeue. And that's now what we are going to look at, how we then use cyclic queue in optimization to mitigate. So muchas gracias. Auf Wiedersehen.